This is Chem Classroom with Auntie Taiwo. If you have not subscribed, kindly do so. So today we'll be going to radioactivity. Now radioactivity is what the spontaneous decay or disintegration of the nucleus of an atom with emission of radiations and release of large amounts of energy. Okay, and in radioactive reactions, we have new elements being formed, unlike your normal chemical reactions whereby you just have formation of compounds, but in this one, new elements are being formed. And we also have what we call the half-life, is the time taken for half of that substance to decay. Okay, so let's go to the board and see the practical question we have on the board. Okay, if 556 gram of a radioisotope whose half-life is 5 days is initially present, what fraction of it will remain after 20 days? Now, this is what we are saying, and this is how I explain to my student. If you have a loaf of bread and it's not in the refrigerator, you know, after some days, it starts to what? To decay. Okay, and you will agree with me that it is not the whole bread that will decay at the same time. No, a part will start to decay. Okay, so now I have some formula here. Now, amount left represents the part of that bread that is still good. Yes. While amount decay is your amount left, you remove it from the initial mass of the bread that was given. Okay, then I have the formula of my half-life. Half-life equals to what? 0.69 divided by K. K is the decay constant. Now, this amount left equals to A is the initial mass divided by 2 raised to power n. Now, n is my what? My final days, like a date that will be given, like a future time. Then initial days is the half-life here. Okay, so these two formula can serve the same purpose. We can use these two formula to calculate the amount left that will be left after a certain date that was given. Okay, but I always encourage students that you must know how to use those two formula, because you can be asked to calculate other things. This one is mainly used for only amount left, but you can be asked to calculate other things. Now, in this second formula, now the NO is the what? What you call the initial mass. The NT is the what? The amount left, and the K is the decay constant, and the T is the future time that was given. So now let's get to work. So I'll be using the first formula. Amount left equals to what? A raised over 2 raised to the power of n. So my n, I'll look for my n first here. N is what? Final days over initial day. The final days here is what? 20 divided by the half-life, that is 5, equals to 4. Yeah, so we can say amount left equals to, my here is the initial mass, which is what? 256 that was given, divided by 2 raised to power what? 4. And 2 raised to power 4 is 16. 256 divided by 16 is going to give me what? 6 grams. Okay, so that's been said. Now let's move to the second formula. This one, students tend to run away from this formula because of maybe perhaps the log reading, but it's never a problem. Okay, so we are going to do log. Okay, before we go for the log, we need to calculate our K. Yes. So my K will now be what? 0.693 divided by what? The half-life. Okay, so we have what? 0.693 divided by what is the half-life? 5. So in all, I have 0.1386 days. Okay, or whatever you choose to use. Okay, so now let's go to our log. NO is the what? 256 divided by NT is what we are looking for. Okay, so then I have what? I have, okay, this on this other side now, I have my K is what? 0.1386 multiplied by the time is what? 20 divided by what? Divided by 2.303. Okay, so in all here, now this log will come to the other side. So I will have 256 divided by nt. So when this log comes to this other side, I'm going to have anti-log in our mathematics. Once it crosses the equality sign, we'll have the anti-log. So everything here, by the time we simplify, we're supposed to have 1.2. So 256 divided by nt equals to what? The antilog of 1.2 is going to give us 16. Okay, so nt here is going to be what? 256 divided by 16. So in all here, I also have what? 16 grams. So we have been able to calculate our amount left using the two formula, and we arrived at the same answer. So if you are being asked to calculate amount decay now, amount decay is going to be what? 256 amount decayed will be 256 minus what? 16 that was gotten. Okay, so we will have what? 240 grams. Okay, that being said, so you can easily solve other examples using these two formula respectively. Is very good. You know how to use this other one. It's not difficult at all. But this one, if you are in a very tight situation and you want to do quick on time for this, for to do fast with your question, you use this. But there are some questions that you just have to come back to this formula and utilize it. Okay, so when next with me, we'll be going to more advanced questions that we'll be solving. Okay, see you some other time. Tell your friends, share, like, and view. Subscribe. Tell your, if you have not subscribed, you are very, very wrong. See you some other time. Thank you.